This is the Chapter 6, Unit 3A test review, starting with problem 13 through the end of the test. Problem 13 says, suppose a company that manufactures computer chips uses the formula C is equal to 8 times n to the 3/4 power plus 2,500 to estimate the cost, C, in dollars of producing n chips. Write an equation that determines the number of chips the company could make for $12,000. Then find the number of chips. Well, first of all, $12,000 is the amount of money they're going to make. So where does it get plugged into the equation? It gets plugged in for the cost, C. So I'm going to start by doing this. Now, you can use either this equation or you can convert n to the 3/4 to the 4th root of n cubed, whichever one makes you happier. But you'll probably be happier with this equation. Then they want us to find the number of chips, so we actually have to go and solve it for n. So first, we're going to subtract the 2,500 from 12,000. So 9,500 is equal to 8 n to the 3/4. And then I'm going to divide by 8 because I solve this like I do any other equation. And then to get rid of an exponent of n to the 3/4, the easiest thing to do is raise the other side of the equation to the reciprocal of that exponent. The reason we raise to the reciprocal is because what do reciprocals do to each other when you multiply them? They become 1. So I really want this side of the equation to say n to the 1st. So now in my calculator, I'm going to do 1187.5, and I'm going to raise that to the 4/3 power. Remember, if you have the old operating system, you need to put the 4/3 in parentheses. So I get the number of chips to be approximately 12,575. Now, why did I round it and not leave it as a decimal? Well, think about this. Computer chips. Can you have like 10.5 computer chips? And don't tell me you cut one in half. No, it doesn't work that way. We usually talk about the number of objects in integer values. In number 14, they want me to write the square root of 15x to the 6th y to the 3rd in exponential form. So, a square root is the same thing as raising to the 1/2 power. Well, then I'm going to distribute that 1/2 to everything inside. So I'm going to raise the 15 to the 1/2 power. I'm going to raise the x to the 6th to the 1/2 power. And I'm going to raise the y to the 3rd to the 1/2 power. I can't do anything to the 15 to the 1/2 power without getting a decimal. But when I simplify this, remember, you're multiplying the exponents together. What is 6 times 1/2? Well, it's 3. And then here, what is 3 times 1/2? It's 3/2 or 1.5. The nice thing about rational exponents is they follow all the same properties of regular exponents. So in order to simplify x to the 3/4 over y to the 3/2 all to the 8th power, all I'm going to do is distribute the 8. So I'm going to raise the numerator to the 8th power, and I'm going to raise the denominator to the 8th power. And all I have to do now is multiply the exponents. So 3/4 times 8 is going to be 6. And then 3/2 times 8 is going to be 12. Oops, that's not x. That should be y to the 12th. And then that's as simplified as I can get because the bases are not the same, so I can't subtract the exponents or anything. Number 16 is a fill in the blank. Numerators of fractional exponents represent blank. So here's an example of a fractional exponent. The numerator of the fractional exponent is just the exponent. The denominator of the fractional exponent represents the root index, or you can say that it represents the nth root. Negative exponents represent reciprocals. Because if you have x to the negative third power, it's the same as 1 over x to the third. It's just the reciprocal. All right, the last problem. There were no instructions, but one might assume that they're asking us to multiply these together. So, with that in mind, these are going to get multiplied together because they're kind of like terms. Now remember, what does 1/2 mean? 1/2 is the same thing as the square root. So the square root of 18 times the square root of 2 is the square root of 36, which we know is 6. When I multiply these together, this is the same as the cube root of x squared times the cube root of x to the 13th. So that's going to be the cube root of x squared times x to the 13th, which is the cube root of x to the 15th. And then y to the 3/5 is the 5th root of y to the 3rd. And y to the 7/5 is the 5th root of y to the 7th. So when I multiply them together, I get the 5th root of y to the 3rd times y to the 7th, which is going to be the 5th root of y to the 10th. Let's make that look like a 10. So now, well, what's the 3rd root of x to the 15th? Well, you can just divide the exponent by the root index. 15 divided by 3 is 5. The 5th root of y to the 10th, it's going to be y squared. And that's the simplified answer. For the performance assessment task, a minus the square root of b times a plus the square root of b had a special name. We ran across something that looked just like this when we did complex numbers. They were called conjugates. With complex numbers, when we multiplied conjugates together, the imaginary components went away. So we were left with a real number. So for radical conjugates, when we multiply them together, we're going to get rid of the radical. So it says, write a product of this form so that the answer, and then there's nothing after that. The intention is that they want the answer to equal 90. And so what you're going to do is you're going to play around with numbers to figure out what do you have to call A and B so that if you multiply these together, it would equal 90. So I want you to think about what happens when you do multiply these together. We get a squared plus a the square root of b minus a the square root of b minus the square root of b squared. Well, these are opposites and they cancel, and the square root of b squared is b. So now I know when I multiply this together, I'm going to get a squared minus b is equal to 90. So you need to play with numbers to determine, well, what can you multiply together and then subtract something, and you're going to get 90. So this is what I did. I thought about perfect squares that were larger than 90 because I'm going to subtract something from it to get 90. So a squared could be 10 times 10, which is 100. But it also could be 11 times 11, which is 121, or it could be 12 times 12, which is 144. And the right answer is, it really doesn't matter which one you pick. There is no one right answer to this problem. So for the sake of argument, I'll pick this one, and I'll say that a is 10. So that a squared is 100. So if a squared is 100, what do I need b to be in order for this to work? Well, then b must be 10 as well. That means that I must multiply together 10 plus the square root of 10 times 10 minus the square root of 10. And when I multiply those together, they should give me 90. So now I'm going to go and check and make sure that this worked. So this is 100 minus 10 to the square root of 10 plus 10 to the square root of 10 minus the square root of 100. Well, these are opposites and they cancel, and I'm left with 100 minus, well, the square root of 100 is 10, which is 90, and it worked. Now again, I could have chosen something else, so I could have instead have chosen a to be 11. If I had done that, a squared is 121, and I want this to equal 90. So 121 minus what number is going to give me 90? Well, it's going to be 31. So instead, I could have done 11 plus the square root of 31, 11 minus the square root of 31. And I bet if I multiplied those together, I would also get 90. So I get 121 minus 11 the square root of 31 plus 11 the square root of 31 minus the square root of, well, 31 times 31 is 961. So these cancel because they're opposites, and I'm left with 121 minus, well, the square root of 961 is 31, and 121 minus 31 is 90. So that answer also would have worked. The problem you'll have on the test will be similar to this. It's just that the number that it'll equal won't be 90. When you multiply those conjugates together, you will be left with a squared minus b is equal to 90. You will need to come up with a perfect square that is larger than the value given, and then determine what b will be from there. Then you will plug it into this equation and multiply it out to make sure that it works. And that is the review for the Chapter 6, Unit 3A test.